Hi, I am Varun Joshi and welcome to day 51 of our Certified Kubernetes Administrator 2025 course. In this final part of our Kubernetes Ingress deep dive, we are going beyond path-based routing and into the world of TLS termination and subdomain-based routing using Route 53, AWS's Certificate Manager, and the AWS Load Balancer controller on Amazon EKS. By end of this lecture, you will know how to secure your apps with valid HTTPS certificates, use custom domains with your EKS cluster, route traffic to different apps using subdomain based ingress rules. This real world setup is the final piece that completes our three-part Kubernetes Ingress series ready for production use. If you are new here, don't forget to check out part 1 and part 2. They lay the groundwork for everything we are doing today. If you don't already have an EKS cluster with AWS Load Balancer controller configured, check out part 2 of this series first because we are working in this part 3 with an assumption that you already have a working EKS cluster along with AWS's load balancer controller configured, because as we have learned in part 1, it is the load balancer controller which is continuously watching for changes in the ingress resource, or maybe in the addition of a new ingress resource, so that it can create a load balancer onto the cloud, or it can modify it based on the modifications that you have done in your ingress resource. So before I move ahead, we have already discussed two prerequisites, that is, you must have watched part 1 and part 2. There is one more thing that I want to highlight. If I go to my browser here, there is a prerequisite section for day 51, and I have also mentioned you must understand how DNS works. Now this is important because we'll be working with Route 53, we'll be registering a domain, and then after that we'll be doing subdomain routing, and you will understand what I'm teaching. But to create that aha moment, I think it would be better if you understand how DNS works under the hood. So I have a lecture in this channel which does just that, so do check that out. With that said, let's get started. So in demo 1 was part of part 2 of this series. In part 3, we'll be concentrating on demo 2. So in demo 2, we'll first be registering a domain using Route 53. A TLS certificate will be issued, and finally, users can access our website using port 443, that is HTTPS. Let's go to the diagrams. Now here I have a slider which is explaining what is that we should improve. Now I cannot ask my end users to access my website using the load balancer's DNS name, which is impractical. Hence, we will be registering a domain. That is one improvement that we can do. Second is our website must be HTTPS. HTTP is not used for any of the trusted website in the internet. Hence, we want our website to be HTTPS. For that, we will be creating a certificate using AWS's Certificate Manager. Now, let's scroll down and understand what will the flow look like in this architecture. So firstly, we will be registering a domain, that is cloud with varjosh.click. I am using the .click TLD because it is extremely cheap. You can get it for $3 a year. And if you are in your learning journey, I would highly encourage you to go and register this domain. In case you cannot, you can watch me do the demos. Let's talk about how the flow will look like. Now, I want you to understand that I will be registering a domain using Route 53. Route 53 will be performing both things for me. First, it is my domain registrar. It is my domain registrar because I will be using Route 53 to register a domain. Secondly, it will be my DNS hosting provider. DNS hosting provider is the one who has your name servers on which your zone file is hosted. In simple terms, whenever there is a fresh query for cloud with varjosh.click, then Route 53's name servers will be authoritative for the answers because my zone file, or essentially my domain, is residing on the name servers of Route 53. And then in our load balancer, we will integrate a certificate which can help us terminate the TLS connection. We understand that whenever there is HTTPS, it is achieved using TLS, and TLS is a layer 7 feature, and our HTTP load balancer in layer 7, it understands HTTPS, which uses TLS. Hence our load balancer can terminate that connection. But to terminate that connection, our load balancer must have a certificate, and we will be providing that certificate to our load balancer. And how we will provide that? We have learned in demo 1 that whatever you want to be configured in your load balancer, you perform those settings in your ingress resource first. Hence, we will be configuring, we will be modifying our ingress resource in such a way that whenever a load balancer is spun for us, it has a certificate integrated with it. Rest everything remains the same. We will have 3 target groups because we have 3 services defined in our ingress, 3 paths defined in our ingress. The iPhone target group will be sending requests to the iPhone pods, Android target group to Android, and so on. Now let's see how the flow will look like. First, Shwetangi was previously accessing load balancer DNS/iPhone. Now, since our website will be HTTPS and it will also have a domain name, she will access using https://cloud with varjosh.click/iPhone. Request will go to the internet, and then the request will go to Route 53 because Route 53 is my DNS hosting provider. Now, I want you to understand clearly, in case the DNS to IP mapping is cached in any of the internet's public resolvers or the ISP of Shwetangi, then the request will not go to Route 53. Only when the ISP does not have this information cached, or the primary DNS resolver of Shwetangi does not have this information cached, only then it will go to Route 53 for name resolution. And once Shwetangi's laptop know the IP address for cloud with varjosh.click, then it can move forward to the load balancer. And this configuration we'll be doing in load balancer, that whenever a request comes for cloud with varjosh.click, you send that request to this load balancer, and once the load balancer has that request, a load balancer will terminate that connection, and then it will forward it to the appropriate target group. In our case, the appropriate target group is of iPhone, and the request will then move to the iPhone pods, and the request will then be catered by our containers which are listening on port 5678. So this is going to be the entire flow. Now let's go to the browser. I'm in the AWS console. I have logged in as IAM user varun.joshi, and the alias for my account is cloud with varjosh-prod. I will go to Route 53 now. Now, if you do not have a domain registered, then you can register your domain using Route 53. Here is the register domain section. You can enter the domain that you want to register. For example, if you want to book myapp.click, then you can check the pricing for myapp.click here itself. Myapp.click is not available. Let's write Varun Joshi just for testing, and if I click on check, it will say it is available and it is just $3 per year. So you can go ahead and register it. For now, I'll go to Route 53. I have already registered a domain called cloudwithvarjosh.click. I will go to the dashboard, and if I click on hosted zone, then you will see there is one zone, that is cloudwithvarjosh.click, and here is the zone file for Cloud with Varjosh. And what we learned was that there are two records that are always there in the zone file, and those two records are name server records and SOA records, start of authority records. So once you register your domain, you should see these things automatically here. Now that this part is understood, what I want to do is I want to now associate a certificate with my domain. So I'll go to Certificate Manager and I will click on request. The certificate is public certificate. I'll click next, and then here it is asking me to provide fully qualified domain name. So what I will do is I will write cloudwithvarjosh.click, because this is the domain name for which I am requesting a certificate. I will keep everything to default. It is cloudwithvarjosh.click, and then I will click on request. And once you request a certificate, it is not that everything is done. So I could be requesting a certificate for amazon.com, but I do not own amazon.com. The domain amazon.com is not owned by me. Then should I be allowed to request the certificate? Yes, you are allowed to request a certificate, but you cannot associate that certificate with that domain until and unless you prove that you own that domain. Because I could go to this ACM and request a certificate for amazon.com, but that does not mean I own amazon.com, which is why often text records are used. So once you register a domain, you will be asked to make an entry in your zone file, and once you make that entry, the place where you are requesting for a certificate will verify that, and only then that certificate will be associated with your domain name. Now, since we are in the AWS's ecosystem and I have used Route 53 to register my domain, and now I am using ACM to request a certificate for that domain, hence I can perform that validation from right here. I do not have to create any records manually. You see cloudwithvarjosh.click pending validation. Now here is the tab I want to click, create records in Route 53. Once I do that, then I am saying that indeed I own this domain, or I can click on view certificates here and it will say it is pending validation. And now I can click on create records in Route 53, and in Route 53 it will automatically create. In case your domain was registered in, let's say, GoDaddy, and you were using AWS's Certificate Manager to request a certificate for your domain, in that scenario you would have to provide some sort of entry in your zone file that resides in the name servers that are hosted by GoDaddy, assuming you used GoDaddy both as domain registrar and DNS hosting provider. Again, watch the DNS lecture in case any confusions in this terminologies. I'll now click on create records, and this has successfully created a record for me. And if I click on list certificates now, it is still saying pending validation, and it should be working in some time. And if I now go to cloudwithvarjosh.click, Previously, I only had 2 records. If I click on refresh, you will see there would be a verification record also created, and here is that CNAME which is used for verifying that indeed I am the one who owns this domain. So if I go to certificates and hit refresh, I should see, let's allow this some time. I had to delete the certificate and recreate this for this success message to appear, because I waited for 4 minutes and still the status didn't change. Hence I recreated it, and now I see success here. So if I go on list certificates, I see that there is a certificate ID which is associated with cloud with varjosh.click. Now what I will need is, I will need the ARN for this certificate, ARN, Amazon resource name. I'll go to Visual Studio Code now, and here our manifests for namespace, iPhone, Android, desktop, they are the same. We have not done any changes. They are same from our demo one, but I want to make changes in 05 ingress.yaml. Now let's see what are the changes that I want to make here. Firstly, let's see what things I have changed. It is internet facing like before. The name I have changed to demo 2. Target type is still IP because I want my pods to directly serve the requests. And then here was the listen ports section, which previously just had port 80. Now I have added port 443 as well. Now I want to show you one more thing. So if I go to my GitHub notes and then I scroll at the top, I have a references section here, and here you can see AWS ALB annotations. So you can visit this to see what all options you have at your disposal when you are using AWS's load balancer controller. There are so many annotations that you can use, and they have done a good job in segregating this. So if you want to see TLS related, you just go to TLS and see what all things you can specify. And the first one you see here is something we are going to use, that is the certificate ARN. So if I go back to my Visual Studio Code here, then I have 2 listener ports now for HTTP and 1 for HTTPS. And we are already aware of this section. I will go to view and I will word wrap this so that we can see properly. Then here are the 2 new settings that I have added. I have added SSL settings. We should be calling it TLS settings, shouldn't we? But as we know, TLS and SSL are used interchangeably, but TLS is the naming that you should be using, because TLS is advanced SSL, so to speak. Now here I have added 2 fields. First is the certificate ARN. We just saw this in the annotations documentation. And then second is SSL redirect. What is SSL redirect? Now there could be users who could be typing HTTP and then my domain name. I want, if someone is accessing using HTTP, they should be redirected to HTTPS. And that is exactly what we are doing here. We are saying SSL redirect port 443, and whenever someone accesses our website on HTTP, they will be redirected to 443. Now these are the only changes I have performed post registering a domain and requesting for a certificate. Now let's change the certificate ARN with the certificate ARN we just received. So let's go here. I will copy this ARN and then I will paste this ARN here. I'll save this, and now I will go to my terminal. I will cd into demo2, and then I will write kubectl apply -f dot. Dot implies that all the YAMLs in this directory should be applied. I'll press enter and it will start doing the magic, creating the namespaces and deploying the YAMLs. And the creation has started. Now if I run kubectl config, I'll have to change my current context's default namespace to app1ns. So let me do that. Kubectl config set context current, and I want the namespace to be app1ns. And then I will run kubectl get pods. I see all the pods are created. I'll write kubectl get svc. All services are also here. And then I will write kubectl get ingress. And I see the ingress that we just created is also here. The host part has an asterisk right now. And then address is this one. This is the address of my load balancer. But before I access this, I want to show you how this load balancer looks like in AWS, what changes you would observe. So let's go to the browser, and then I will go to EC2, and then in EC2 I want to go to the load balancers. Now here is the load balancer that we just created, cloud with varjosh -ingress -demo2. So if I click on this, and all these fields we have already explored in demo 1, I now want to go to listeners and rules, and you see now we have two listeners. One is on port 80, one is listening on port 80, and another on port 443. And if you see the default action in HTTP listener, it is to redirect to HTTPS, and that is exactly what we configured. And you see here default SSL and TLS certificate, and this is our certificate, and here is the ID of that certificate. It starts with E6E, and if I go here, I will see the same E6E. That is the ID of our certificate, identifier of our certificate. Rest everything is pretty much the same. So let's do one thing. I'll go to the details section. I will copy the DNS name and I'll type it here. I'm using the DNS name. Okay, I'll press enter, and you see this is the certificate error because it is automatically redirecting to HTTPS, and our website does not have a certificate. But Varun, we associated the certificate with cloud with varjosh.click, not with this. And right now we have just associated the certificate. We have not made any entry in route 53. We have not told route 53 yet that whenever a request comes for this website, you redirect it to this load balancer, because that configuration must be done at the route 53 level. So let's go here, and I will click on create record, and then for which subdomain, I do not have a subdomain yet, so I want the entry for my root, for my naked domain, for my apex domain. All these names, apex, root, naked, all these are for your domain name. So if I am using amazon.com, amazon.com is the apex domain, is the root domain, is the naked domain. So in our scenario, it is cloud with varjosh.click. Here I'm going to create an alias record, and it is asking me route traffic to. I will route the traffic to alias to application and classic load balancer. I will click here, choose the region. I'm using Ohio, so I will use that, and you will use the region that you are using. Now is the interesting part. Choose the load balancer. Where is it that you want to redirect the requests that come for cloud with varjosh.click? And what I want here is I want to redirect it to the ingress that we just created, the load balancer that we just created, which is named cloud with varjosh ingress demo 2. So I'll click on this, and then I will just say create record, and it is now creating the record for us. Understand, when we were using the load balancer's DNS name, we received an HTTP error. I could have clicked on advanced and go to proceed with this, but again, You do not want to do this in production environments. Hence, we registered a domain, associated a certificate with it, and now we are going to access our website. I will write cloud with varjosh.click and I will press enter, and I want you to guess what will happen if I click enter. I will land on the desktop users page because I have not supplied any path, and the default is the catch-all path is forwarding everything to the target group that is associated with the desktop user service. And behind the desktop user service, we have the pods that are catering to our desktop users, and in those pods we have containers which are listening on port 5678. So I'll press enter, and voila, we are in the page of desktop users. And if I write now /iphone here, I will land in the iPhone users page, and similarly if I write Android here, I will land in the Android user page. So I hope you have now understood how this works. Now our task is to clean this up. So I will go to my terminal, I will clear my screen, and let's also do a describe on this here, kubectl describe ingress, and then what is the name of the ingress? It is ingress demo 2, and then here is our ingress successfully reconciled. That is what we wanted, and here you can also see the ARN of your certificate. Now again, I'll clear my screen. I will run kubectl delete -f. I'll add a dot. It will delete everything for me now. Now let's do one more thing. I will go to my AWS console, and then I will also delete the entry that we made in Route 53, because in demo 3 we will be making a different entry and the name of the load balancer will also change. Hence, I do not need this record. So I will be deleting the alias record that I created. Here I will click on delete record, and then I will delete it. In AWS, if you have a choice between alias and CNAME, always pick alias, because the queries to alias records, they are not charged. Now I am not deleting my certificate, and you will know why I am not doing so in a little while. So let's go to our diagrams and see what we want to do in demo 3. So I will scroll down. Demo 3 is name-based routing. Firstly, what is name-based routing? Name-based routing is also called subdomain routing. So we have learned that if I go to my Visual Studio Code and I want to show you something, let's write it here itself. If I write here amazon.com, in this scenario, .com is the top level domain and Amazon is the second level domain. And then if I add here cart, then cart is the subdomain. Hence, whenever you want to do subdomain based routing, which is also called named based routing, then you will be using the technique that we will be using in demo 3. Now, previously we were doing path based routing, which is why we always provided /iphone or /android. So if I go to my browser, that is what we provided, /android or iphone, or we access the default path. But with named based routing, what you do is you add the subdomain here. So for example, if I want to access my iPhone service, I will add iPhone here, and my Android user will be adding Android here, and my desktop users will be catch also. If someone is accessing my website from their laptop, then they will be served by the desktop SVC. That is what we wanted. Now the flow and everything else remains pretty much the same. There are only a few changes that we have done in the manifest, and I will walk through those changes along with you. So let's go to Visual Studio Code, and here as well the flow will remain pretty much the same. It is just that the user Shwetangi will now have to add an iPhone subdomain because we are adhering to named based routing. So let's go to Visual Studio Code, and now I will just clear this and I will close this, and then I will minimize this. I'll go to demo 3. Namespace YAML remains the same. I want to show you the iPhone YAML. Here, this manifest, I have done a few changes. Now index is being served at the root. And why we are serving this at the root now? Previously we had iPhone here, but now we are not doing path based routing. So what we are saying is, whenever someone hits iPhone, this index can be served from the root itself. Previously we had to do that because we had a path specified. And then if I scroll down, previously we were monitoring /iphone /index.html, but now since this file is available at the root, what I mean by the root is it is available in right here. So we are saying just monitor this file. And similarly, when it comes to Android, we are doing the same. Index.html resides here, and we are asking the load balancer, the target groups in the load balancer, to monitor this file to tell us whether the pods are healthy or not. Similarly, for desktop service, we are saying index is at the root and you have to monitor this path. Then if I go to Ingress, here are the few changes that we have done, and I want to detail those changes with you. I will word wrap this. Now let's see this manifest. We are naming this load balancer demo 3 now, which is expected, and rules are also the same. This part is also the same. But in the certificate ARN part, we will have two certificates. But Varun, why two certificates? I want you to know that if I only register one certificate, for example, let's say the certificate that I registered was this star.cloudwithvarjosh.click. Let's say if I registered only this certificate. Now the problem would be, if someone accesses cloudwithvarjosh.click, then this will not work. Because why this will not work? This will not work because we do not have certificate for this. So we have certificate for anything that precedes this dot, but if I just provide this, then my wildcard certificate will not work. Previously we only had one certificate. We had certificate for only this, and this worked because we were using path based routing. But now we are using subdomain based routing. In that scenario, we will have to request two certificates, one for our subdomains like iPhone and Android, and one for our Apex domain. So if someone comes and visits cloudwithvarjosh.click, especially our desktop users, then they should also not see any certificate errors. Hence, we will be requesting two certificates here, one wildcard and one for our Apex domain. Let's clear this. So we will be requesting two certificates, and let's do it right away. So we already have a certificate for, so if I go to this screen and I click here, we already have certificate for cloudwithvarjosh.click. I will request another certificate, and this time what I will provide is, I'll provide an asterisk here, which is kind of a wildcard certificate, and I will write cloudwithvarjosh.click. Now you could request multiple certificates. You could have written it like this. You could have written, instead of this asterisk, you could have written iPhone here, and then you would also request another certificate for Android. But I don't want to do that. I will just write asterisk here, and then I will scroll down. What is this? Add another name to this. Oh, you can add multiple names to the certificate. Hold on. I didn't know about this. Oh, this will just work for subdomain. Let me just cancel this. Oh, this is interesting. So if I go here, can I just edit this and also add that one? Can I do that? No, this is for tags. I don't think I can edit it right here. So let me do one thing. Let me try to request certificate for my Apex and also for my wildcard. Let's see if that works here. So one I will request for cloud with varjosh.click, and another I will add another name to this certificate, and that will be a wildcard certificate. And here I can write cloud with varjosh.click. And you see, let's see if I can do that. Here are the validation methods. So since I'm using Route 53, I can use this one. If your domain registrar was someone else, then you would be using email validation. So let's go here, DNS validation. I will click on request and let's see how this works. I'll click on create records. Okay, the records are already there. Success. Oh, this is pretty cool. So I'll go here. Can't see from here which one is which. If I click on this one, this has only one. And then let me choose this one. This one has both of them. So let me just copy this ARN. I will go to my Visual Studio Code and let's only add one ARN here and let's see what happens. You could use multiple certificates as well. And when I talk about secure environments, you would see that there are different certificates used for multiple subdomains. So if I talk about Google, probably they would be using different certificates for maps.google.com, mail.google.com, and then another for the apex domain, that is just google.com. So let's see how this works. I'm not sure how this will work, but let's test this. So ALB Ingress SSL redirect, this is from the previous section. Now the spec section in this changes. Let's do one thing. I will compare this with the Ingress in demo 2. So I will open this here and then I will split this to right and then I will close this one. I will send this away, and here I want to compare these, and I will just word wrap both of these. This word wrap and this is already word wrapped. Now let's see what is happening. ALB Ingress class name is ALB for both of them, that is understood. Here we know rules was a list and HTTP had paths here, and paths was a list, and that is why we could specify multiple paths here. So if I jump here, we still have the rules section, which is understood, but now we have something called host, and in the host section is where we specify the subdomain. So the subdomain here is iPhone, and whenever iphone.cwvj.click is requested, then the request should be sent to the service that is for iPhone, and that service is listening on port 80. Extremely simple. Only changes here, you had multiple paths, we had 3 paths. Here you have 3 hosts, just like that. Nothing else changes, everything else remains the same. The concepts, the backend, the path type, the path, all of these remain the same. And why this is slash? This is slash because now we are serving our index.html from the root. And similarly, if I go to Android, you have the slash path, and anything that comes for android.cloud.with.varjosh.click will be forwarded to Android SVC, and similarly for catch all. So if someone accesses the apex domain, then they will be redirected to the desktop service. This is extremely simple. I hope this makes sense to you. Now let's go to our terminal. I'm already in demo 2, so I'll go one step back, then I will cd into demo 3, and here I will run kubectl apply -f dot, and this will apply all the manifests. So everything else you pretty much have an idea how they will look, but Ingress is an interesting one here. So if I run kubectl get ingress, then here, what is this? In the host section, now you have these subdomains along with the naked domain, and here is the load balancer's DNS name. Now we will have to make certain entries in Route 53, because whenever traffic comes for iphone.cloud.with.varjosh.click, then how does my DNS hosting provider know where to send that. So let's go to Route 53. I'll go to my browser and then I will come to this screen and then I will click on create record. This time we will enter a subdomain. Previously what we did was we just switched this and then we provided the details here, but this time I want to write here iPhone, and for iPhone I want to send it to the application load balancer. Region is Ohio. Routing policy would be simple. Now this is not an AWS course, Route 53 course, otherwise I would have explained all these things to you, but maybe another time. So I'll choose the load balancer here, which is demo 3. Now I will click on create record. So for iPhone it is created. Now I want to create it for Android as well. Android, and this will also be an alias, and I want it to go to application load balancer. Region is Ohio again, and in Ohio region I want this to go to this load balancer. I'll click on create record. We are not done yet, so we have created the records for subdomains Android and iPhone, but we have not created the record for our Apex domain. So let's do that now. Alias, and here I will choose this load balancer. Region will be Ohio again, and then the load balancer will be this one, that is demo 3. I will click on create records. While these records are being created, let's go to load balancer. I will refresh this because we should have demo 3 now. Here is demo 3. I will uncheck demo 2 from here, and then I want to show you the listeners and rules. HTTP, anything on HTTP, you redirect it to 443. Now let's see how the rules look like on this screen. We already have this certificate associated. I will click on these 4 rules, and if I go here, you see the magic. Anything that is for iPhone, you send it to this target group, and this target group we know is associated with the pods that are sitting behind the iPhone SVC. Similarly, we have for Android, and then this one is our catch-all, which is sending everything to this target group, and this target group is directly sending it to the pod IPs of the pods that are sitting behind the desktop SVC. If I go to target groups here, we see 3 target groups, which is expected. If I go to Android one, both the pods are healthy because we are now directly monitoring /index.html, which is available in the root. For Android, we see targets, both pod IPs are here and they are listening on port 5678. These things we have already discussed. Now I want to finally show you how this screen looks like. I will click on cloud with varjosh.click, and here this is how this looks like. If I click on Android, this is how this will look like. So anything that comes for this, the request will be sent to this load balancer. And here I want to show you one more thing. So if I copy this and I go to my terminal and I write ns lookup this, then you see these are the IPs that are associated with my load balancer. And you can also directly check this. So this was the name that was available in the Route 53 screen. So if I go to my browser again and then I go to the load balancer screen, I'll go to load balancers, and then if I copy this name from here and I go back to my terminal and I perform an ns lookup for this, then you will see that these are the same IPs that we saw here, and this answer is non-authoritative because my browser would have already cached the results. Now let's access our website. I will write iphone.cloud.with.varjosh.click and I'll press enter, and you see I am being served by my iPhone pods. And if I write Android here, then it will work in the similar way, Android, and you see we are landed in this section, and in the Android users page If I do not provide anything, then I should be landed in the desktop service, which I am. Now I want to do one more thing here before I let you go. I want to change this S to just HTTP, and I want to show you how the redirection works. I'll press enter, and you see I am automatically redirected to the HTTPS site. That completes this demo, and that wraps up part 3 of our Kubernetes Ingress series. You now have a working solution for TLS with AWS ACM, custom domain setup via Route 53, ingress routing based on subdomains like iphone.cwvj.click. Up next, we will be exploring the Gateway API, the next generation alternative to Ingress. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.